Hello. This short video will describe the final project for DSCI 325 for the spring 2021 semester. Okay, let's go ahead and show you the details then. The final project consists of 3 problems. Problem number 1, which has to do with the Twin Cities Metro commute data, and that project is to be completed in SQL. Problem number 2 has to do with Minnesota school discipline, and that can be done either in R or Python. And then problem number 3 is to have you make a connection with an API, and that can be done in R or Python as well. So let's describe each of these problems briefly. Problem number 1, again, has to do with the commute times around the Twin Cities area. There is a Colab document that you're going to want to use for this, and that is final_metro commute time. That can be found on my GitHub site. There's also a database file that is metrocommute.db, and that can be found on the OneDrive. So if we go back to the course webpage here, the data files are on a OneDrive. You can see that the Metro DB and then also the information for the Minnesota schools problem as well, the second problem, are provided here. Okay, so a little bit of background on this. The Metro Light Rail Transit Company in the Twin Cities is making plans to do an expansion, and they're planning to go to the south and west out towards Eden Prairie here. And your goal is to use census data to determine if that is the best direction to go with their expansion. And what we're going to use to do that is I've obtained information on commute time from the Census Bureau. I also have commute time for public transportation, and then I also have information about population as well. We're going to divide our map into 4 quadrants. Quadrant 1, 2, 3, 4 is described here. Okay, what are the files that are, or the tables, excuse me, that are contained within the database? We have a cities and towns, which identifies all of the cities and towns in the surrounding Twin Cities area that are to be included in this analysis. So those are found in the cities and towns table. The census location info has information about how much land there is in each of those cities and towns. And it also has an important key here, the GeoID, which is going to be used to make a connection between the location information and the commute time information that is provided in the last table. So the last table here is just census commute time, and again, the important information here is it has population and both commute time for public transportation and otherwise. Okay, so this problem starts out with just lots of different code chunks and has you tell me what's going on with each of those. Hopefully these are fairly straightforward for you. Once the problems or the code chunks get a little bit larger, so when I say run code chunk number 5, obviously you're going to want to go do that in your Colab document that I have provided for this problem. Okay. These problems should be getting increasingly more challenging. Down in code chunk 9, you're going to have to do your own coding to identify the different quadrants, and of course that's going to be based on the latitude and longitude measurements. So I've given you the structure for the case when statements. You just need to fill in how to identify those different quadrants using the latitude and longitude measurements. Finally, code chunk 10 is actually going to compute the summaries that we need. Notice here that I am computing the average commute time for public transportation. I have a where statement here and also a group by statement that would allow me to calculate that for the different quadrants. I've asked you below here to identify what each of these are doing. So here's the main table. So again, code chunk number 10 is set up to do commute time for public transportation, so that'll be this column right here. You need to just modify code chunk number 10 in order to compute the average commute time and then also the average population per square mile. Okay, so what is given to us is the land area is given to us in square meters. You're going to have to figure out how to convert the land area in square meters into land area for square miles. So go ahead and Google, do whatever you need to figure out how to do that conversion. What I want here is the average population per square mile in each of those quadrants. Okay, I don't want the average population per square meter. Okay, that's going to be an unreasonable number. But we usually describe population in square miles. So there needs to be a little conversion that is done there and then compute that average quantity. Now, in my code, I actually did that expression right inside the average here. So I changed my commute time to an expression that converted the information about square meters into square miles, and then I again obtained an expression for population per square mile. So that expression went right inside the average here. Okay. If that's not clear, go ahead and reach out to me and I will help you step through that. Okay, problem number 2 then is about the Minnesota school discipline. Okay, this can be done in R or Python. I have actually done an analysis and I did mine in Python. Okay, so I gave you a Colab document that you can use to kind of work off of if you would like. The background of this is a Minnesota Supreme Court case in August 2016 basically forced the Minnesota Department of Education to keep track of disciplinary actions of all middle and high school students, and maybe even elementary. Okay, what I did is I did my analysis for all 6 races, I think it was. So my analysis included all 6 races. You are to essentially do what I did, except using only 3 races: black, Hispanics, and whites. Okay. There are 3 files again. These need to be joined together. The first one is the Minnesota school discipline data. Okay. The second is the Minnesota school information, which essentially the only thing I need out of this file is this NCESID ID, and that is the U.S. Census Bureau's ID for each school district in the United States. Now I need that because the census data, which is contained here, uses that key or has that key. So this, again, Minnesota Schools Information allows me to go from this disciplinary file over to the census file. Okay, and that's all included, again, in this document, the Colab document, where I go through the joins, showed you how those are done. Okay, so essentially you have to mimic what I did, except you're only considering 3 races instead of all 6 races like I had done. There is a description here of exactly what I did. Okay, so I read in the discipline data. I excluded any school districts that do not have complete information for race. Okay, so the code is actually going to use a total column that is provided in this disciplinary file. But that total is only available when all 6 races have information available. So because you are only going to be working with 3 races, you're going to need to create a new total in the disciplinary file. And that total is going to be, again, for black, Hispanics, and whites. Okay? You're going to need that total when you do the joins with the other tables. When you get down to the census data, you'll see in my code that I keep track of the information from all 6 races. Again, you will only need to be keeping track of information for the Black, Hispanics, and whites. So if you see a select statement that has 6 different races in it, you should reduce that down to the 3 races that you're interested in. Towards the latter end of my processing, I do some calculations with what's called the chi-square statistic. I showed you examples here for the Forest Lake School District. Okay, again, my example has all 6 races. Yours will have only the 3 races. So your expressions will be a little bit smaller than the examples that I did in the Colab document. But there's some steps that we have to go through in order to get that chi-square, and that is to obtain the census data, compute proportions for each of the races that you're interested in. Okay. And then you're going to compute the expected counts for Black, Hispanic, and whites again. And then you need to calculate this chi-square for each school district. Here's the calculations for that chi-square. Again, you will only have 3 races in the calculation of your chi-square. Once we have that chi-square value, which essentially measures the amount of discrepancy between the actual counts and the expected counts, we will use that to rank the school districts from best to worst. The smallest chi-square is going to be the best school district, because that means it is closely mimicking the race distribution of those obtaining or getting disciplinary actions or having disciplinary actions, closely mimics that in the community. So a small chi-square is better here. So you're going to do your rankings based on that chi-square value. For this problem, there's actually only 2 outcomes that I need, and that is a top 10 list of who's doing the best, and then the bottom 10 list of who's doing the worst. Obviously, the top 10 list can just be obtained using a head command, and the bottom 10 can be obtained using a tail command. Again, if you have questions about what needs to be done there, you can reach out to me. Finally, problem number 3. I left problem number 3 very vague, and there's only 3 criteria that I'm going to have you that are necessary for this problem. And you can use Python or R. You can pull data from any API you want. We did a Yelp example in class in Python, and we did a Twitter example in class in R. If you want to use Yelp or Twitter, you're more than welcome to, but you don't have to. All I need is you to pull data using the API, and then to create some sort of summary from the API. This first summary should be something that can be placed into a table. So if it's a top 10 list, that's fine. If it's a Yelp API and you only want restaurants that have an average rating greater than 4, that's fine. You can decide what summary you want to create. It just needs to be in a table. And then you're going to create another summary, but this one's going to be a visual summary. And you need to make some sort of graphic or chart. So I don't really care what your summaries are of. Again, this problem is kind of wide open, and you can do whatever you want with that. Okay, so that's problem number 3. This entire project is worth 100 points here. 40 points on problem 1, 40 points on problem 2, and then the API problem is worth 20 points. Good luck with this project. Have fun with it. And if you have questions, make sure and reach out to me. Thank you very much, and have a good day.